So if you look at number 1, does the infinite series have a sum? If you say yes, what is that sum? And then it does ask you to show some work. There's not a lot of work we have to show. So in number 1, we have the series 10, 5, 5 halves, 5 fourths. Maggie, what's going on with this series? Yeah, she said you're multiplying by 1/2, so the R value is 1/2. What does that mean about the sum then? Does it have a sum? Yes, so this series does have a sum because this number is less than 1. So as long as the absolute value of that number is less than 1, then it has a sum. So Maggie, how do we find the sum? 10 divided by 1 minus 1/2. So your first term divided by 1 minus R. No clue what's going on. And Maggie, what did you get when you got that? I think my notes are crashing. So 10 divided by 1 minus 1/2, Maggie, is 20. So for number 1, you should have had the value of 20. I know I didn't ask you to do the second one, but if you look at the second one, it's 1, 4, 7, and 10. So I only said the odds, but taking a peek at that second one, if you have 1, 4, 7, 10, again, the question is, does this series have a sum? Jillian? Why not? Yeah, well, this is, what's going on with this one? Right. So number 2 does not have a sum because it's arithmetic. You're adding 3. So that means the points are just going to continually increase at a constant rate of 3 forever. So there would be no sum because it's kind of like you would have a straight line that just goes up and up and up, except it's a set of points instead of a straight line. So if it's arithmetic, there is no sum. It must be geometric, that R value must be less than 1. So arithmetic sequence has no sum. Alright, so let's look at number 3. We have 2/3, 1, 3 halves, 9 fourths. Does that one have a sum? If so, what's the R value? Julian? Why not? Yeah, so there is no sum because you're multiplying by 3 halves, which is greater than 1. So make sure you're writing a reason as to why you're saying there's no sum. There's no sum because the R value is 3 halves. 3 halves is larger than 1. Looking at number 5, right underneath it, this one is in sigma notation. So we have K equals 1. That could be an A, it could be an N, it could be pretty much any variable. The infinity symbol is on the top. That tells us that it's an infinite series. So the infinity symbol is on the top there. And then we have, in parentheses, 101 over 100, and then K minus 1. Anybody know what the R value is in this one? Odette, what's R?
100.
Right, this number right here with the exponent, that's our R value. So when it's in geometric sequence, the R is attached to the exponent. So the R would be 101 over 100. Odette, is that bigger than 1? Yeah, it's barely bigger than 1, but it is bigger than 1. So that means, Odette, there is no sum. So as long as it's bigger than 1, there isn't a sum. Questions? So the next 2 odd problems ask you to write this series in sigma notation. And then again, it asks you to show some work. We have 6, 18, 54, and then it goes on forever. What would you need to do in order to write a series in sigma notation? Julia, what do you think you need to do?
You have to first find out if it's geometric or arithmetic.
Yeah, we need to know if it's geometric or arithmetic so you can write the equation. What's going on with this one, Julia?
It's geometric.
Yeah, this one's geometric because
It's being multiplied by 3.
it's being multiplied by 3. So this one would not have a sum because the R value is bigger than 1, but they're asking you to write it in sigma notation. So remember, sigma notation should look like number 5. So I should have the sigma term in the problem. So we gotta have a little sigma. Julia, what goes underneath the sigma?
And equals 1.
Yeah, when you create it and it's a geometric or arithmetic sequence or series, it's always n equals 1. And then on the top, if this is an infinite series, what do you place on the top? The infinity symbol. So that little 8 that fell over. So you have n equals 1. When it's arithmetic or geometric, it's always 1. And then because this is infinite, you put the infinity symbol at the top. And then we need the geometric equation that goes along with this series. And what would that equation be?
6 parentheses 3 and then 2 n minus 1 power.
So you have your first term, the r, and then that n minus 1 exponent. So that would be the equation for a geometric series. It's the same equation for a geometric sequence. It's just in series notation once you use the sigma because now you're adding the terms together. Questions so far? So if you look at the back page, there's one other one, number 9, that asks you to write it in sigma notation. And then the last one, 11, we'll look at as those partial sums. So again, you have to decide, is it arithmetic or geometric? We have 80, negative 20, 5, negative 5 fourths. So arithmetic or geometric? Rebecca, what do you think, arithmetic or geometric?
Geometry.
And what are you doing to get to the next term?
We're multiplying by -1/4.
So she said you're multiplying by -1/4. Would this one have a sum if you were asked to find it? Yeah, this R value, the absolute value of R is less than 1. So this one would have a sum if we were asked to find the sum. So instead it says place it in sigma notation. So we would have n equals 1, the infinity sign at the top, and then Rebecca, what's the equation?
80 parentheses -1/4 substituting n minus 1 power.
Nice. Questions? So you have your sigma, starts at 1, goes to infinity, the first term, the ratio, and then that ratio is with the n minus 1 exponent. So the last one on here of the odd problem says to graph the first 5 partial sums, determine if the series has a sum, and then if so, find that sum. So starting with the first 5 partial sums, the first one would be 3. Connor, what are you doing then to get the next partial sum? Go, let's go. But how would you find the partial sum? What does it mean to get a partial sum? Yeah, you add them together. So a partial sum is taking each little piece of the series and just adding to get to the next value. So 3 and 3/4, Connor, would be 15/4. Or it would also be 3.75. So then, Emma, S3, what's that really mean you're doing?
Adding 3 and 2.76.
Right, so then you're taking the previous sum, the sum of the first 2 terms, you're adding 3/16 to that. What did you get, Emma?
I put it over 256.
Say it again.
I put it over
Okay.
1,000 over 256.
1,008. So 1,008, she said, over 256. She's keeping the exact fraction. Emma, if you do a calculator on your desk, what is that as a decimal?
3.14.
Or 3.94. So the next partial sum, it said the first 5. So the sum of the first 4 would mean taking what you previously have and adding the next value. Maggie, did you get a number for the sum of 4? 3.98, is that what you said? And then the last one, the sum of 5, means you're adding those first 5 numbers together. And Maddie, what do you have for that last one? 3.9. Any questions with those partial sums? So by looking at those numbers, Maddie, you can see that they're getting closer and closer and closer to 4. So the partial sums would be getting closer to 4, therefore the sum is going to be 4. And that's by using the partial sums. Because they kind of have a limit, they're reaching that same number. So looking at the graph, I'm going to just count by 2's here, make it a little more spaced out. Get the points separated a little more. So the first one was 3. And then we have 3.75. And those last points are just getting closer and closer and closer to 5. Does anyone have questions on infinite series? So as I said, I have a worksheet that is a review of series. So not just the infinite series, but also the finite ones. There are 3 formulas that go along with series. You have 2 formulas for when it's finite, one for geometric, one for arithmetic. And then we have the formula when it's infinite. And we'll write those at the top so you got those to look at. So at the top of the worksheet, I suggest that you maybe write those formulas up there so that you have something to look at, something to start kind of memorizing. But there's a little bit of space at the top. So we have the infinite. It must be geometric, and that formula for the sum is the first term and then 1 minus r. So when it's infinite, it must be geometric. The formula is the first term, 1 minus r. And then remember the absolute value of r has to be less than 1. If it's arithmetic, there is no sum. The other option would be if it was a finite, meaning it has an end term. And we have our arithmetic versus the geometric form. So the arithmetic sum says take n which is the number of terms, how many terms are in the series. In parentheses, we're adding the first and the last terms together. And then you're dividing that by 2. So you're taking the pairs and taking the sum of each pair, but the sum of each pair is the same. We're using the number of terms because then I know how many pairs we have, and then that gets cut in half. And then the other form, when it's geometric, is the first term minus the last term. That number gets multiplied by r, and then 1 minus r. There are no parentheses in there, so that r doesn't get multiplied by the difference of the first 2 terms. The r just gets multiplied by the last term. So the remaining 17 minutes of the period are yours. There is a back to this, and unfortunately, I have the answers at the bottom. They just copied very lightly. I don't know if I didn't write hard enough, but you can kind of see the answers down there. Tomorrow we're going to do another review, and then your series test is on Monday. Questions? The rest of next week you have Tuesday off. Wednesday, Thursday, Friday we'll review for your final exam. So grab a partner. If you want to work with somebody, please ask questions.